Now let's prove these three basic identities. Now none of these are new, you've seen them all before and you know how to prove them. It's just a matter of explaining what you know. So we've already talked about them extensively in our unit on combinatorics. The reason we're looking at them again is because this is a real crossover area of our syllabus that comes into our Pascal's triangle and binomial expansions part, but it also comes into our concept of combinatorics. How do you prove these identities using combinatorics? Just explain simply in a sentence what they mean. So here, how many ways can you choose nothing from n items? Well, there's only one way you can do that. You can sit back and say, I choose nothing. There, you've done it. There's only one way you can do that. How many ways can you choose n items from n items? Well, that's choosing everything. So you say, I choose everything. Done. There's only one way that you can do that. And then this one is that one that's based on complements. If you've chosen something, you've also not chosen the leftovers, okay? The easiest way to prove this one is to throw some numbers into it and then use those numbers in an example. So I could say, all right, if there are 6 items on a menu and I'm going to choose 2 of them to eat, then there's the same number of ways that I can do that as the number of ways that I can choose the 4 items that I'm not going to eat. So my proof then would just consist of some sentences. There is only one way to choose none of the items or all of the items. The number of ways to choose a given number of items is equal to the number of ways you can leave out the items you didn't choose. So proving those 3 identities in Pascal's triangle using combinatorics means write sentences and just explain how you can choose a certain number of items from another number of items. They're quite simple and easy to do that way. You can also prove them algebraically, but that relies on using the n choose r formula. Now we know that n choose r can be written like this, it can also be written like this, and the formula for it is this. Okay, so it relies on knowing that formula there. So if we're proving that n choose 0 is 1, we can say that the left-hand side is n factorial on the top, n minus 0 factorial on the bottom, 0 factorial. This gives us the n factorial. We know that 0 factorial is 1, so we end up with 1, which is equal to the right-hand side. Very straightforward. Similarly here, n choose 1, we have n factorial over n minus 1 factorial. 1 factorial is just 1. And so if we unroll the top and say this is n times n minus 1 factorial, then the n minus 1 factorials will cancel. We've got n over 1, which is just n, and we get the right-hand side. And the last one, n choose r is equal to n choose n minus r. All we need to do is apply the formula. So the left-hand side is simple. You literally just state the formula. But the right-hand side, we literally have n factorial on the top, and then we have n minus bracket n minus r factorial on the bottom. And that means that we end up with n minus n, the n's disappear, but the negative out the front of these brackets and the minus r actually gives us r factorial for this section on the bottom and the n minus 1. So you can see here that really these terms are just swapped around the other way in either case.